derivatives and integrals are built off of this idea of a limit. Okay? Those are the three main things we're going to do. We're going to start with limits and then build from this idea. We're going to build derivatives. From that idea, we're going to build integrals. Okay? And it all starts here. It all starts with Galileo doing a little experiment. He was rolling a ball down a little slip and slide. Okay? And he was doing calculations, and he created an equation. He calculated that if you square the time it's been rolling for, that's how far it has traveled. Does that make sense? So what he did was he started calculating average speeds to find some information on this. He said, okay, I'm going to find my change in distance, my total change in distance, and divide it by the total time traveled to get an average rate of change. Does that make sense, you guys? So if he had his little equation, he said, okay, after 3 seconds, you should have traveled 3 squared feet, or 9 feet. And then he subtracted it from where he started. At 0 seconds, you traveled 0 feet. So you take that difference and you get 9 feet. If you take that and you divide by the total time, you can get an average rate of change. Does that make sense? And that's what he did here. Did you guys see that? Now, I got a speeding ticket in Missouri by a cop just sitting alone by himself in the middle of the street stopping me. No radar gun or anything, and he says, "You were speeding." And this is I'm like, "What are you talking about?" And he said they had a helicopter set up and they painted 2 white lines in the street. It was like a 1/4 mile. And so they had the total distance, and then they divided it by how much time it took me to do it. And with that is an average. And their proof is, if you averaged over this length of time, this speed, at one point, you should have been going faster than that. Does that make sense, you guys? If your average was over the speed limit, then at one point, you should have been going faster than that. Does that make sense? And I was like, you got me with your mathematics. You got me. But that's actually true. That's a true story. That's actually what happened. And that's going off of this idea, this average rate of change. If you wanted to go and find out, obviously at the beginning, you're not going 3 feet per second because you just start. If you're starting, you're going 0 to start your speed. And then as you get towards 3 seconds, you should be going faster than this, because if you start at 0 and you end at something and you average 3, you should be going faster. Does that make sense, you guys? And as a ball is rolling down a little ramp, it should be picking up speed as it goes. So if I want to know what the speed is, the instantaneous speed at 3 seconds, well, that's a little trickier to do. Because what that's saying is instantaneous speed is like finding out the speed someone's going by taking a picture of them. Does that make sense? It's like, okay, let's look at this picture of Mr. Amos. And I'm like, this? It's saying, like, how fast is he going at exactly that time? And you can't really do that. Does that make sense, Jackie? So, yeah, does it make sense, Amina? Okay, so what you need to do, you're right, it doesn't make sense. You can't take a speed, an instantaneous speed off a picture. So what you can do, though, is take really, really small increments. Did you guys remember doing this in Small World? Yeah, you take really, really small increments. So what I did here is I wanted to find my speed at a certain time. So I tried the interval, 3 seconds, and then I also calculated my distance after 3.05 seconds. A really, really small increment, right around 3 seconds. Does that make sense? And I'm going to say that's my instantaneous, or use this little itty-bitty small increment of time. Because with a small increment of time, you can get a change in distance. I have moved. And you take that total movement divided by that increment to get, it's still an average rate of change, but, the smaller that increment gets, it gets closer and closer to what you're really going at that time. Does that make sense, Chris? That's great. So here I'm just going through the same calculations. My change in distance would be, I take my time squared, that gives me my distance after 3.05 seconds. I subtract my distance after 3 seconds. And then I divide that by my total time traveled, or 3.05 minus 3, which is going to be 0.05 seconds. And I get, again, using my units, my change in s, this is in feet, this is in seconds, so when you divide feet by seconds, you're going to get your speed. When you divide the distance by time, you're going to get a speed. So right in this small increment, I'm averaging about, I look like I'm going about about 6.05 feet per second, and you can go 3.0005. You can go smaller and smaller increments. You can play that game. You know what I'm saying? Get smaller and smaller, and what are we getting closer and closer to? Well, here's another way to do it, which we didn't do last year. We didn't do in Small World. What if I said this? What if I said, okay, I want to know my instantaneous speed at 3 seconds, and what I'm going to do is, but the 2 points I'm going to plug in are 3 seconds into my t squared function, and I'm also going to plug in 3 plus h seconds, where h is just this tiny little smidgen of an increment. You know what I'm saying? Where h would be that 0.05 in this case. That's what h would be. This would be like 3 plus 0.05. H is just that small difference between the two values. Does that make sense? What we're going to do, Eve? Okay. So, if I got my t and my t squared, this is time and this is my s. So, at 3, this is going to be 3 squared. And after a little more, 3 plus h seconds, this is going to be 3 plus h squared. Yes? Those are my 2 points. I take the 3 and I plug it into the equation to find the distance I travel, 3 squared. I take my 3 plus h time, which is 3, plus a little more, a little bitty smidgen. And I'm going to take that whole thing and dump it into my distance equation. Does that make sense, these 2 points, Lauren? Okay? Now we're going to do the same thing. I'm going to do change in y over change in x. And that's all we're going to do all first semester. Change in y over change in x. That's going to equal this point minus this point over my change in x. This point minus this point. And you could do it the other way, that's fine. Doesn't matter again which one you use first, as long as you stay consistent. But what's going to happen now in this denominator? Yeah, the 3's will cancel out. And you can multiply this 3 plus h out. Again, that's 3 plus h times 3 plus h. So you got to FOIL all that out. And you wind up with this. 3 squared plus 6h plus h squared, and then minus that 3 squared over h. You combine some like terms here, and you get 6h plus h squared over h. So that is my feet per second that I'm going. Now, if I want to get h really, really small, Katie, can I just set, can I set h equal to 0? Why can I not set h equal to 0? Yeah, so that's illegal, right? And this was the big fight. When people started doing this, they were calling them crazy because they're saying that you're doing you're doing fake math. You can't, there's nothing you can do. You can't divide by 0. But check this out. You guys ready? The difference, what we're going to do with limits, is say, okay, I'm not going to say h equals 0. I'm going to say h approaches 0. And use that very specific different word. I'm never going to say h is equal to 0. But I'm going to say that h is going to approach 0. That increments get so small that the increment is approaching 0. Well, here's what kind of happens, and we can play this little game. Now these can't cancel out. Yes? Because there's a plus sign there. Be careful with that when we do our algebra. You can only do if everything's all multiplied. That's when you can start canceling out. But what you can do, Jackie, is that there's an h in common here. Do you see it? So you can factor an h out. And once you factor that h out, it's h times parentheses 6 plus h. Does anyone have any questions on that factoring out? Because we're going to be doing a whole bunch of this. Again, if you multiply that back in, this would be 6h plus h squared. Okay? But I factor an h out. Now I have h times 6 plus h divided by h. You have two things multiplied together on top now. Now you can cancel out. Does that make sense? And when you do that, you're left with 6 plus h. Is that change in distance over change in time? That's what that speed is equal to. And now, can you technically plug in h is equal to 0, Michelle? Like, do I have a denominator anymore? No, so really you kind of can. You can kind of play this, well, when h gets really small, you can just say it's equal to 0, and then your speed is 6 feet per second. Does that make sense?